Hello everyone. So myself Vedan Zadok and today we are going to explain the remaining two types of reaction, type of chemical reactions we can say, and this time we are going to solve the last two, which is remaining. So we have displacement reaction. So displacement reaction is basically nothing but for example, you can take Fe plus CuSO4 results FeSO4 plus Cu. Okay, so here as you can see that this is nothing but you can see this is the iron, this is the copper. Okay, don't see to the SO4. Okay, because in displacement reaction this doesn't matter. Okay, this is the reactant, this is the product. Okay, tell me what difference you can see. Exactly. The Fe, the iron has displaced copper and joined with SO4. So when iron is added in copper sulfate, the copper gets displaced by the iron and it converts into ferric sulfate. Okay, so why this happened? This is nothing but a reactivity test, which you can say that here the displacement means Fe displaced Cu, okay, and joined with SO4. FeSO4 and Cu in separate. First, Fe was separate, then he wanted to bond with SO4, so he joined with SO4, but he kicked away copper. But how are we going to know that who is going to take place of whom? Okay, that is important. Like, why does the iron kick copper? Like, how? So keep one rule in mind: who is more powerful, uh, he will rule. Okay, means iron is more powerful than copper. Like, powerful you can say in reactivity. Iron is more reactive than copper. So copper got displaced by iron. If basically it is not, but if copper was more reactive than iron, and if they show this equation, then it would be wrong. But here, iron is more reactive than copper, so it displaced copper and joined with SO4. Okay, so how are we going to come to know who is more reactive, who is less reactive? Okay, don't worry, we have here the table. Okay, so we have potassium. Okay, this is the reactivity table. Okay, this all elements come here down. I don't have space here, so I have written in horizontally, but make sure to write it vertically. Okay, K N A C A M G A G A L Z N F E P B H C U H G A G A U. Okay, for this you have to know the symbol. You have to know the symbols of the elements. So what is K? K is potassium, Na is sodium, Ca is calcium, Mg is magnesium, Al is aluminium, Zn is zinc, Fe is iron, Pb is lead, H is hydrogen, Cu is copper, Hg is mercury, Ag is silver, Au is gold. Okay, this table goes like this. As you go down, the last stop is AU. As you go down and down, okay, the reactivity will decrease. Okay, for example, potassium is the most reactive, and gold is the least in this table. So the potassium has the power to displace gold. uh, as we had the example that Fe plus CuSO4 results FeSO4 plus Cu. Why that happened, I'll tell you. Okay, firstly find the Fe and Cu. Here is Fe, this is Cu. Okay, we can clearly see that Cu Fe is upside, means it is more reactive, and Cu is less reactive than Fe. So Fe is more powerful than Cu because Fe is more reactive. As you can see, uh, as the table goes down, the reactivity decreases. It is like that. This, then this, then this. Cu is here, Fe is here. So Fe is more powerful, Cu is less powerful. And if there would be a chance for the displacement reaction of iron and potassium, potassium will displace iron because potassium is at the top. Na can also displace iron, calcium can also, Mg can also, aluminum can also, zinc can also, but Pb, hydrogen, copper, Hg, Ag, and gold can't displace iron. Only the elements which are upside to the iron can displace the iron. Okay, so this was the displacement reaction. I hope you all understand. If you want more detailed version of only for displacement reaction, make sure to comment. It's all free. I'll make a succession. Okay, so last one reaction, which is double displacement reaction. Okay, so this reaction is totally similar to the displacement reaction, but here the things are getting double. Means here two displacement we can see. Here only one displacement we can see, that was Fe displacing Cu. That was the one only. But here two we can see. For example, we can take here Na2 plus SO4 plus BaCl2 PaSO4 plus 2NaCl. Okay, this in here we can see that this upper side is reactant, this is product. What you can see is that this SO4 and Cl2 are at the same position uh, in both reactant and this product side, but the only thing that changed is that Na was with SO4 in the reactant side, Na was with SO4, but to the product side it attached to chlorine. Same here, Ba was with chlorine, but it got attached with SO4, which is inverse. Okay, so here two Na attached to Cl and Ba attached to a surface. Okay, got it? Here the these last terms will not change. Only the first terms will be changed. Got it? So I hope you all liked, and by the way, this was the last fourth one. Okay, I think I by mistakenly wrote 3 here, but it was the last one. Double displacement was the last. So we covered combination reaction, displacement reaction, double displacement reaction, and decomposition reaction. Four types of chemical reaction we have covered through the two series. Okay, so if you want any detailed version of any four of these or any other topic related to science, chemistry, you can just comment down. Okay, so thank you for watching. Make sure to like and subscribe for more amazing videos, and yeah, see you in the next video.